Welcome everyone. I'm Thomas Weeks. I'm going to be giving a presentation this morning for you all. Hands-on hacking. This is for Cybersecurity Career Week. Nice NIST doing a capture the flag. I'm giving you guys a overview of what the system's all about, how to play. It's going to be from for the next hour and a half or so. And then the CTF itself is going to start around noon, or right at noon, I believe, and run through, looks like Thursday at 6 p.m., I believe. So get ready to join at noon, but until then, sit back and enjoy the show. So you can join and play the CTF by browsing, pointing your browser to go.vacr.io/careerweek. Click the start button. It'll look kind of like this. And once it does, it'll ask you to log in. You'll need to use either your school login credentials, your Google or Microsoft login. And once you get in, it'll present you with a Jeopardy-style playing board. If you've never seen this type of CTF before, it's Jeopardy style, which is modeled after an old television game show. Everyone says they've seen it, but I wonder how many people today have seen Jeopardy. It's where you pick a category like ancient Greece for $500, and then you pick the question, and you actually pick the answer, and then you give the question, give the answer in the form of a question. So anyway, you pick a category, and you solve the challenge basically. So that's how our Jeopardy-style CTFs work. So in our competition, your CTF can be played as an individual or team. So you'll be asked, do you want to just play solo or do you want to play a part of a team? I'm not sure what the school is recommending, but most people in these ad hoc scenarios just play solo. It sounds like I'm remote, but I guess you all are all together. By the way, if there are any questions, please just feel free to unmute or ask a question in chat. I think Maureen, are you watching chat, Maureen? I think that's how we're doing this.
Yes, I am.
All right, awesome. And so like we talked about, there's multiple capture the flag scenario or formats. So there's Jeopardy style, which we're playing. There's attack defend, red versus blue. There's puzzle CTFs, all kinds of different formats. They play them in everywhere from hacker conferences like DEF CON to the one we host every year is VMI's Cyber Fusion event up at VMI, Virginia Military Institute, and those are collegiate level. So there's kind of commercial nonprofits, and then there's universities and colleges, and there's actual high school versions. In this case, and they can be hosted by a variety of different groups, from teachers, professors to individual CTF teams. Some cybersecurity clubs like to run their own capture the flags. They even get a commercial sponsors to sponsor the events and buy T-shirts and food, and so they're really a lot of fun. It's a great way for companies to connect with students too. A lot of people don't realize this, but the people who win these capture the flags, it's a notch in your belt. It's something you want to put on your resume, and people look for it. In fact, when we play capture the flags here in this region, the people who sponsor our events get the names of the winners because they want their resumes. So it's not insignificant. It's not just a game. Besides, we do it mainly for teaching and learning. But if you win a CTF, you want to put that on your resume. In fact, when you go to interviews, they're going to ask you, so what kind of challenges did you solve, or what were you good at? Because that's what your area of expertise is going to be in. So the DoD and government also started doing a lot of capture the flags, running these national competitions to find good players, so they can find good red team, blue team folks for doing cybersecurity for the government. So it's a big deal. So, like we said, it's a fun way to learn more about cybersecurity topics. It's a picture of a bunch of students here at Virginia Tech that came out on an early Saturday morning. It wasn't for free food and it wasn't for donuts. It was to play the CTF. So a lot of university students are motivated by this kind of stuff. So it's a lot of fun, super popular, especially with, like I said, with cyber clubs. A really well-designed CTF kind of caters to a wide range of abilities. You don't need to feel intimidated. A lot of people are intimidated, like I don't know anything about cybersecurity. And it's okay. There's beginner level content that you can just Google and answer. And then there's more in-depth stuff where you're actually hacking on boxes and trying to find weaknesses in systems. And this focuses on real world skills. I have to remind people, some specifically parents, they get a little nervous when they hear us teaching kids to hack. Like, isn't that dangerous? It's like, well, that's kind of the concept. You cannot have a good defense if you don't understand the offense. And there are offense parts of, for example, red teams that work for the government and corporations, but it's kind of like, I tell people, it's kind of like the Harry Potter Defense Against the Dark Arts class. You got these kids learning about dark arts so they can learn how to defend themselves against them. So that's kind of what we're doing. And it's great for team building events, skill assessments, and just teaching basic problem solving. You can't really teach problem solving out of a book as well as you can, but just by doing. And so this is an opportunity to get your hands dirty and roll up your sleeves and check out cybersecurity and see if it's for you. The categories we're going over today are customized for the NICE Workforce Framework job categories. So we have, you may have already heard of some of these: oversight and governance, design and development, implementation and operation, protection and defense, investigation, cyberspace intelligence, and cyberspace effects. And so these are basically groupings of the job framework. So they're grouped into these categories, so that because there's a dizzying array of various kind of nice knowledge, skills, and abilities, and so they've kind of grouped them into these kind of more manageable category groupings. So our CTF also is grouped into these. When you click on a challenge, the point value, like I said, indicates how hard the challenge is going to be. The challenge of the name of the challenge is often a hint to what's going on. You know what the nature of this challenge is. And if you're not sure, you can always kind of Google the title or Google some of the phrases you see in the description and kind of get on the right path. You want to be sure to kind of step outside the box, because some of these are kind of mind benders. So they're all challenge kind of puzzles based challenges. So some have multiple choice questions and answers. Some have a file attachment you have to download, and some may have an internet target you have to click on to explore further. If there is a file, its name is often also a hint, but you need to be careful. Not all files have the correct file extensions. They may be designed to throw you off. They may have no file extension at all. So sometimes you'll have to either open your file in a text editor like Notepad, or run some utilities against it, or peek inside it with a hex editor to find out what's going on. Are there any names mentioned anywhere in the challenge body itself and challenge description? And then once you get the flag, you submit it, and it must be a perfect match. Now we have what's called regular expression based answers. So you can, for example, if you miss an uppercase or lowercase, or you use a different character instead of spaces, we can accommodate for a lot of that in our regular expression based answers. So it's not a huge deal, but for example, if the answer to a challenge is Bob Smith, we may just take Smith, for example, as well. Take Bob Smith or anything that ends in Smith. We try to leave it fairly open-ended, so if we know that you're on the right path, that you're good to go. So this is an example of what a file attachment would look like. If you do get something like that, for example, in this case, it says that it's a TXT file. We're going to solve this challenge here in a little bit. But in this case, it's called README, and it says, can you read me and find the flag? And it gives you this text-based file attachment. Now, if you try to open this in Windows always looks at the file extension and looks at the file extension as instruction as to what to do with a file. Other operating systems like OS X and Linux and other Unixes, they don't look at the file extension as much. They look at the first few bytes, the first few characters inside the file to determine what type of file it is. We're going to look at that. In this case, this is a readme.txt file, but I open it up in a text editor and I just see gobbledygook. So sometimes those file extensions, like I mentioned earlier, are left off. Sometimes they're wrong. It's all part of the challenge. So how can we identify file types? If you're using Linux or Kali Linux, you're at a distinct advantage. You can drop to the command line and use the file command, and it'll tell you what it is. In this case, we saw this file is named readme. I did an ls here, and I ran the file space readme.txt, and it says, readme.txt is a PDF document. So what do you know? It's not a text file after all. That means I would need to open that with a PDF editor, and you can also open it in a hex editor down here. If you know what you're doing, you've done this before, you can kind of recognize hexadecimal characters and what they mean. Then you can open it in a hex editor and see very quickly, this is a PDF document, not just because it says PDF here, because PDFs always start with the hexadecimal characters 255044. So I know right away if I see that, that's a PDF. And in fact, you can start seeing other things surface if you scan further down. This is the hexadecimal side, and this is the ASCII encoded view of the file. So it's the same file, both sides, just in different views. So it does help to learn to know about magic numbers. I'm not sure if this is going to open up. Let me try this. File signatures. Yeah, this is it. So for example, if I open this file with a hex editor and I saw this is starting with 255044 and I didn't know what that was, I could search for 255044. There we go. That's a PDF document. So this is the hex file signature at the beginning of the file. This is what it looks like in ASCII, displayed in ASCII, and this is the type of file it is. This describes what it is over here. So if I wanted to say, for example, what's a JPEG? You just search for JPEG, and there's multiple things for JPEG. I'm getting off my script here, but here's all the ones for JPEG, RAW, or JFIF. So these all start with FFD8 something, FFD8. And so if it starts with that, then I know it's a JPEG image. Or I may see part of the magic number, it may be corrupted, and I can actually rebuild the corrupted data from that. So this is all really, really good. If you're going to be doing this on Linux, the hexedit command is typically what I use, just from the command line. If you're on Windows, the HDX is a popular hex editor. You can download that, I think, for free. Some people use Notepad++, I believe, also on Windows. And I think there's a good graphical one on Linux too. The name escapes me just now, but GHEX, I think it's GHEX. So those are all really good, but it doesn't do you a lot of good if you don't know about the magic numbers. So you can just go out to Wikipedia, look up file signatures. I think that's the article that's actually referenced. I'll get back to my presentation mode here. I'll just scroll through. It makes it easier. So let's look at the sample challenges. Categories investigation. You can look at this README file. So I'm going to go over here to the CTF. It's not actually running yet, but I'm an admin, so I can get in there and poke around. So I'm going to be in the investigation. Here we go, investigation. And this is called README. Click on README. It says, can you read me? So this is that file we were just talking about. I'm going to click it, and it's going to download. There you go, downloaded. Now on Linux, if I pull this up, it's probably going to recognize that it's a PDF right off the bat. So I'm not going to click on it. I'm going to do it the hard way. So I'm going to go ahead and drop to a command line and say, let's go to my downloads and look at my last few files here. Here's the README file, and this is where we're talking about. I would start poking around. Actually, first thing I typically do is do a file, because that's the no-brainer. Okay, so yeah, it's a PDF. If I pull this up into an editor, you could not edit this file with a text editor. You'll see it starts with some ASCII, but it's quickly devolves into a bunch of binary that you can't really do anything with, and you don't want to mess with it. You don't want to write to this file. So I'm going to quit out of that. And if I really wanted to do some exploring, I'd probably use hexedit for my README. There we go. Now this is hex on the left, ASCII on the right, and I can scroll through here. I can search for things, but really all I'm needing to see is what this header is. This is definitely a PDF, so I'm going to kick out of that. And if I was on Windows at this point, I would probably rename or move the file from its current name to something with the correct extension on it. And then my operating system would be able to decipher it, and I could open it up in whatever PDF viewer I'm using. So,
Hey,
and
Tom,
there we, yeah.
Professor Adams from Germana.
Hey,
So when I look at the hex, what you just brought up in a couple last minute, it
yeah.
looks very similar to Wireshark's readout.
Well, yeah. It's I mean, it's all binary under the hood. So, um, in that way, it's
Can I
all
use the
everything.
same tools to read the hex values in Wireshark?
No, no, Wireshark won't be able to interpret PDFs and files like that.
Okay,
Um, it's a couple layers down in the communication stack. So where a file being transmitted via FTP or HTTPS, for example, Wireshark is looking at the protocols that encapsulate and envelop
okay,
that PDF file. So you'll still see the PDF flow, for example, but it'll be surrounded by HTTP, which is surrounded by TCP, which or is then encapsulated by IP, and so it goes on down on the stack until it hits the wire and goes to its destination. So
right.
Wireshark is more interested in those communication envelopes than it is the actual data. This is the actual data of the thing that was being sent. Now, that being said, if you get a PCAP file, and you'll see this in some of the challenges, this is a good question. Um, Later on, you'll see some of the PCAP files actually have content of people downloading files like this PDF, for example. And you can tell Wireshark, hey, Wireshark, take this communication stream between these two computers and file carve, discover, find for me, and extract any files that you find. So it'll find JPEGs and PNGs. Like if you hit a web page, every single one of the graphics that are coming up to your browser are being transferred via HTTP, and Wireshark will see those and allow you to extract the individual images from that communication stream. So it
Can I
may look the
mention,
same. I mean, it's all just binaries, um, um, bits and bytes, right? But the protocols for TCP/IP, for example, and then the communication service layer on top of that, HTTP, are all encapsulated, and that's the raw data inside a PCAP file. If you look at it with a hex editor.
okay, thanks. I have our team working on for upcoming VMI for 2025. So we're
Oh,
going
cool,
through all the challenges right now.
excellent. And just to say, you can you can solve PCAP CTF challenges with a hex editor. In fact, I just had a high schooler. I'm training a Cyber Cup team, and um, we were going over. Well, I just taught them about hex editing, and the next week we are going to look at Wireshark. And so we looked at hex editing files, and so when you have a hammer, everything looks like a nail, right? And so this is one really sharp girl in our group. She's probably the sharpest one we have. She's like, "Oh, I already solved half the networking challenges." I'm like, "How'd you do it? We haven't gone over Wireshark yet." She's like, "I use hex edit," and I'm like, "Excuse me?" And she opened up the PCAP files in hex edit and found the flags. They may have been embedded inside PDFs that were inside HTTP transports, but she found them and solved the challenges with a hex editor. I was like, that's awesome. So you can actually solve a number of these challenges just by because it's all just binary and hex under the hood. So it's all
Yeah,
how
that's what
we.
I was getting at because see the similarity. Um, and my students are starting to dig into the binary level now. But
Yes,
yeah,
yeah,
appreciate that,
absolutely.
man.
Yeah. So I mean, this is the rendered PDF. But if we look inside it, sometimes you'll be able to see ASCII. Let me actually, I'm getting off script here, but let me go ahead and just scratch this itch. So if I wanted to pump this through strings, I have no idea what I'm going to see here. I'll pump this through less, and then search for flag. Let's see. Okay, I'm not going to see the data because it's rendering it as it looks like it's rendering it as graphics. So once in a while, if a PDF is written a certain way, you can actually pull the text out of the PDF and as rendered as text. But that's not the case in this specific case. But so in this case, I had the PDF, and I'm going to get the answer. I like to have bring open a text editor. So I can because I can't. Oh, I can copy this. There we go. I can copy it directly out. Sometimes they'll do that as graphics, and you can't copy it out. You have to type it. I hate that. So let me go ahead and go over here. Excuse me. And I'd paste the answer in here. Now, a lot of CTFs, they have an answer format. They have a flag format. So at the cyber range, our generic flag format is flag, curly brackets, data, curly brackets. And most all of our answers are all our newer answers since 2021 at least will accept either the data within the brackets or the entire thing. That's why I was talking about regular expression answers earlier. That's just the nature of how we write ours. So, and a lot of teachers don't know this, and they'll have both forms. They'll have both this form as well as the unbracketed form. So they'll have both forms of answers. And then they also get into the mix up of, hey, well, what if I want to put accept upper and lowercase, and they start doing upper and lowercase combinations, and then you end up with 15 or 20 potential answers. So it's much easier to do what's called regular expression. I'm talking to you teachers now. It's much easier to do regular expression based answers, which would look something like this. That's a regular expression answer that will take flag with and without the flag surrounding, as well as all upper and lowercase combinations. So just FYI for you teachers. So good question. Got me off a little, but that's exactly the kind of exploration we want to do in this. So that was the README, and that was the answer for that one. Now I think David originally envisioned having a trivia category. We ended up not doing that, but just wanted to touch on the cybersecurity careers. If you go out to cyberseek.org, is we have a really cool utility for kind of finding cybersecurity jobs and kind of exploring what jobs do what and how they're interrelated, how they flow into each other. If you ever seen an episode of like I don't know, one of the hacking CSIs or something, they're kind of Hollywood type stuff, but some of what they talk about the different divisions, about having a digital forensics person and having an attack and vulnerabilities person, the guy, the scary little geek behind the keyboard, and then you have the officers with guns, they're doing physical security. So you have all those different job categories. They do all work together, and so this maps that kind of stuff out. So if you're interested in, well, I'm more interested in, for example, pen testing under cyberspace effects, or I'm more interested in cyber crime, digital evidence under the investigation category. This will help you map that out. And speaking of which, here's the framework, the nice framework that they put together. So that's where it's actually defined. If you click on that, I'm not going to spend too much time on that because we're focused on the CTF. But there's also a great site for cybersecurity pathways called Cyberseek. Check that out. So let's get into another challenge. This is going to be in the oversight and governance category. So oversight and governance, and these are kind of new categories from my understanding, grouping of categories. This is kind of where folks would go if they were more interested in defining policy and compliance, cybersecurity compliance, leadership management skills, risk analysis, that kind of thing. So these kind of categories. And this one challenge is called Use It or Lose It. Let me just go ahead and go over to the challenge itself. Oversight and governance. Use it or lose it. Here we go. Now, again, the first part's usually a hint. And this principle, this principle of cybersecurity CIA triad has to do with ensuring that information can be used where, when, and where it's needed. So if you know about CIA, let's pretend we don't know about CIA. So CIA, this is not the CIA, but the CIA triad in cybersecurity. What is the CIA triad? Why is it important? This is by Fortinet, the guys who make firewalls, so it's kind of cool. Okay, so C is confidentiality, I is integrity, and A is availability. So the principle of CIA that has to do with ensuring that information can be used when and where it's needed. So someone in the audience answer. Which one of those three Is this pointing this towards? Confidentiality, integrity, or availability? Just from the words, we haven't even got into really what it is. Go ahead and unmute. Principle.
The chat, we have several folks chiming in saying availability.
Yay, availability. So availability just means can you get to it when you need to get to it? So if, for example, let's talk about each one of these real quick. So confidentiality, is it encrypted? Is it secure? In a nutshell. Integrity, has it been fiddled with? Do you know it's in the original state it was when it was sent? Is it reliable? And availability, can you get to it? So this is kind of like aspects of a website. So is the website up? Does it have an SSL certificate? Is it digitally signed? Do we know this is who they say they are? You'll get warnings up on your browser if a certificate's invalid, right? It says my connection is secure, so I have integrity. My SSL cert is good, and confidentiality. It's encrypted, so no one between me and Fortinet can read my web session with like Wireshark. Okay, so CIA, and so this one's dealing with A. So we would do availability. And in my case, I can't actually play because I'm the admin. It hasn't started yet, but there's my answer, so it matches the answer. So I would get the points for this one. And so I now have points for that one. I have points for the README one. All right. All right. Another common category you see in CTFs is one of cryptography, very popular. So changing a clear text into a ciphertext, something that can be encrypted. The difference, people often ask, well, isn't hashing encryption? And they'll ask about some other ways of encoding messages. Encoding messages is not necessarily encrypting, and hashing is not encrypting. Encrypting is the ability to take a communication you want to make secret, you want to keep secret, and putting it into a form where it can be safely shared and transmitted out, and only the recipient can decode it, but it is decodable. Hashes, on the other hand, are just a single one-way encodings that can't be undone. A really good example is the XOR operator. You can take any file and any string and XOR or exclusive OR them together. That's a Boolean mathematical operation, and it creates a ciphertext that can be shared out. And if the other person has the key that it was created with, they can decrypt it. And in fact, a lot of more advanced algorithms are based on that simple Boolean operator XOR. That being said, the challenge, and that's called a PSK-based XOR encryption. So PSA is pre-shared key, and the hard part, like for example, if you have a spy out in the field and you want to send him an encrypted message, he has in his pocket or in his computer or whatever, the pre-shared key, the way of decoding it, what he needs to be able to apply that XOR, what the key is for that XOR operator, or what that passphrase is, or what the key is for the encryption process. And so he's already got that. The difficult part in pre-shared keys is getting the key to the person securely. Because how do you securely get someone a key if they're not physically with you? That's very, very difficult. And it's a really basic problem that's addressed with various things. Instead of in the old days, they'd use pre-shared keys. They'd use like verses from the Bible or some book, or a skip pattern where you skip every few letters in the text to extract the message, and that became problematic. So some mathematicians and computer science folks came up with what's called dual key encryption or asymmetric key encryption. And that's where everyone has a public key and a private key. You may have heard those terms used. If you ever use GPG or PGP, OpenGPG, those are programs that employ asymmetric key encryption, and every person has a public key they share openly with everyone, and then has a private key they use to just encode and decode messages sent to them. So it's really nice, a really nice system. Can't get too much deeper than that in this context today, but if you want to learn more about it, install GPG under your system and start using it. You can securely send bank recs. You should never, for example, send your Social Security information or your bank records over email. It's like a postcard on the internet. Anyone can read it. But if you add PGP or GPG encryption to that, you can then attach files that are encrypted and be sure no one on the planet, not even the NSA, can read your email, and can in turn take the whatever secrets you're sending. So it's called personally strong encryption. I recommend everyone check out GPG. But that's encryption. There's also other challenge types that use just encodings. So ASCII encoding, for example, we saw that a second ago. We saw we looked at a file and we saw ASCII, and then we saw the hex equivalent of that. Underneath, if I hit the letter A on my keyboard to the computer, or underneath the layer of ASCII, that's just a decimal code 65. Okay, and 65 breaks down into in the computer level, it's all binary. It's all ones and zeros, and which can be represented as either binary or hexadecimal. So these are just different encodings. They're not really encrypted, but different ways of viewing the same data. I'm going to show you real quick. So that README file. Here's what it looks like rendered, and then. And a lot of people don't get this right off the bat. I'm sure this sounds like a lot of our listeners are more advanced, but so this is the hexadecimal view of this data over here. Now this hexadecimal view, this is just for us humans. Computers don't actually use hexadecimal. They only use binary. It's just easier. This is much more concise in 2 bytes than 00100101. So it's much easier to represent things to humans in hex than it is in binary, which would just be unintelligible. It's kind of unruly. So that's why we have different encodings. But beyond that, you can then take a message that's in ASCII, for example. So I'm getting off my beaten path again, but it's path less traveled. So say hello world, and if I want to view that, if I want to encode that in base 64, then I could transmit this in the and it wouldn't be in the clear, but it's not encrypted. There's no secret key here. This can be decoded by anyone. In fact, a lot of people, web developers, will use base 64 to quote hide their secrets in the URL, but it's pretty obvious when you see a string like this, or if it has like a let's do it, make it have an equal sign at the end. If it has like a couple equal signs, that's obviously a dead giveaway. This is base 64 encoded, which is trivial. If someone intercepts this in Wireshark, then they can say, hey, this guy tried to send a secret. Looks like they're base 64, so I'll just do a base 64 decode, and there you go. So it's not encrypted, it's just encoded in a different encoding scheme. So besides base 64, then in ASCII, there's UU encode, which is a really old form of encoding. Back when the internet was based on 7 bits instead of 8 bits, they'd have to convert all the 8 bits to 7 bits. So you came with UU encoding. Then there's ROT ciphers, Caesar ciphers. Caesar ciphers was one of the ones that Julius Caesar used to actually send messages to his generals in the field. They would write out messages on a spiraled staff of a certain diameter and length, and write onto the paper going around the staff and send it out in the field. And only the field commanders had the staff of the exact same size and length. So that was a really simple cipher. Then the ROT cipher is a rotation cipher. You can literally take the alphabet and rotate it by a certain number of characters. For example, 13 is the famous one, ROT 13. I think I use rotix over here, number 13. And I shouldn't be getting off my script, but there we go. So that just took the alphabet and rotated by 13 characters. So that's called a rot cipher. Very easy to decode also. Other simple monoarithmetic ciphers are substitution ciphers. So this is where, just randomly substitute letters for other letters. Really simple to break because you can do what's called frequency analysis. Any of these simple ciphers you can do frequency analysis on, and quickly kind of crack the most common vowels are like E and A, and you can identify spaces, and then suddenly you can start cracking it fairly easily through frequency analysis. So I'm not going to get too deep into those. Here's some more crypto resources. If you're doing CTFs, you'll definitely want to take note of these down here. I don't know about Sprot 13. You can do that from the command line. I always like dropping to the command line and doing some of these things before I use website on-site sites. But a lot of younger folks use like the online tools. The thing is, if you're offline and you can't get to it, or so if someone's blocked you with a proxy, then you may not be able to get to some of your favorite tools. So CyberChef is a really popular one. There's actually a usable URL that's for installing CyberChef if you want to run it yourself. But most people just grab or look for cyberchef.org. There it is. And this is a really good recipe base. They call it CyberChef because you have these recipes over here, and you can take messages like this and paste it into the input field and say, I think I want to do a rot. Let me try rot 13. And there it is. So you just add these recipes together, and I could say, show this to me in hex, and drag that recipe over. Now it shows it to me in hex. So it's super powerful, really, really cool little utility. But again, it's better to understand how the tools work, and I teach the command line first, and then teach these kind of tools. That's a really popular one. Another one is decode.fr. It's a .French website, and it comes up in French. You got to click on this to get it in English, and you can do the same thing. Just show me rot ciphers. Here's a rot cipher, rot 13, rot 47, and you click on one of these, and you input your data here and decrypt, and it'll do all the rots. There you go. So really cool. What's that?
Like rot. And
which one do you like?
All.
You like decode?
Yeah, the reason is we'll select all. It'll give us the answer quicker in a tournament and save time.
That's true. You typically, for simple things, simple encryptions and encodings, do like decode. For more complicated multi-level challenges, you're going to need to use CyberChef. For example, something is going from ASCII to some other encoding, and then has encryption on top of that, for example. Then you're gonna want to play around with it on CyberChef.
Yeah, we teach the same list that you have up there now. The only thing we didn't real complicated, we've noticed there was a problem in Virginia Cyber Range with John the Ripper cracking a little more of your advanced 100 points or 60 points, that it just takes forever. So we try to load John the Ripper on our own stuff to try to speed it up.
Yeah. Yep. It's a really great tool, especially if you got good dictionaries. You can do a lot. Do you teach about the RockU dictionary?
We do. We do.
That's an
but
excellent dictionary.
John has its own word list.
Yes.
And find limitations on that. And then, of course, if you want to build a profile, we might move to Hydra or others, but I don't want to get you too much off topic.
Oh, that's fine. I kind of got my script to go over today, but yeah, I don't think I haven't had any John the Ripper or password cracking in this specific CTF today, but yeah, it's
Hashcat works really well too.
Yep, Hashcat, that's excellent. And that's that's a little different, right? You're actually doing hashing. So because hashing is a one-way operation, you can throw a dictionary at it and look at hashes by generating the hashes of the dictionary and then comparing the hashes. For example, when you log into your bank, banks never record passwords. It's just you don't do that because you become a hacker target, and eventually your database will get leaked. So what you do is you hash the passwords. Sometimes you use variable work hashing or variable work algorithms.
Well, we do a lot of attacking on wireless, and so we're the TCP fourth handshake to get the hash values, get the username, passwords. And
oh yeah.
Oh yeah. Yeah, I know you know, Tom.
Oh, it's good. It's good to talk about though. All right, let's look at another challenge under protection and defense. And so this is the category that has things like forensics and monitoring threat vulnerability. Systems engineers might be under this this category grouping of jobs, as well as things like enterprise security. And I kind of decoded a lot of the the government has its own unique kind of geek speak for job definitions and things, but translating that to the kind of civilian world and to the commercial world, that's where you typically see these forensics experts, incident response people, systems engineers, enterprise security people, threats and vulnerability analysis, things like that. Now we're going to look at it. The shift cipher is the name of this challenge. Let's get back over here and look at, there it is, shift cipher 5. So this one says, and of course this is a hint. I don't know if it's a hint as so much as just tells you what to do. What's the password? And so this is the data here. I'm going to copy that out, and I'm going to, since this is a pretty simple one, I'm going to just go directly to decode FR. Go back here, French, and this is the shift cipher. So I'm just going to search for shift, and there it is, right at the top, shift cipher. Pop that in there, decrypt. Oh, there we go. Okay, so there's all these iterations, and the statistically best chance is the one here at the top. So the password is please change me, and it was asking us what's the password. So that's it. So I copied that out. And when you guys speak, if you can say your names too, because I know I met some of you, but I can't see your faces. So please change me. There we go. All right, I get points for that. That was a pretty simple one there. Other challenge types, you'll often see web challenges. So this could be as simple as look at this web page and find the answer, to hack this web page or find the vulnerability in this web page and exploit it. So we have various approaches to solving these kind of problems, from just opening. I typically look at page source first. So how many people of you guys regularly look at page source when you go out to a challenge? I hope some of you. So in this case, like I'm out here on Wikipedia, for example. You can go do it a couple different ways. You can do developer mode and F12 and look at it over here. Here's the source. All the DOMs and the different layers of the encoding for the website are here. I tend to just hit Control U first, just view source, and this actually drops me directly to the source for the web page. And you can typically, like if I want to see, hey, I wonder where they're hosting this, or I wonder what blog they're using. You can open up something like this and scroll to the top or bottom, look at the headers, and let me go back to the top and say signatures is Node.js, HTML classes. Start looking at this and you can see, oops, darn it. You can see what they're using under the hood. So this is Wikipedia. This is using MetaWiki. So that's the tool they're using. So you can see if they're using WordPress, you'll see WordPress mentioned. And so just digging in behind the scenes of a web page by viewing sources, very powerful. It's one of the first things you want to do when you're checking out a website. So developer, we talked about the developer panel, just saw that a second ago. You can look at network traffic between the client and the server. You can use curl to examine the full response from the command line. I like using curl. I also like using links. I can do a links dump of any web page. Let me go out to this one. Let's try a web page. Paste this in, and it'll give me a kind of an ASCII dump of that web page. And I like doing this, for example, and then grepping for my answer. So grip, CIA. Boom, and there's all kinds of just pulled. I didn't have to hit the web page. I can just do this and quickly extract exactly what I want to look for out of that website. You can also view source and do the same thing with source. So very, very powerful way of interacting with websites other than just pointing and clicking on them. You can also look for robots files. I don't know if this other site has a robots file, but if it did, robots file is how a web server tells search engines and robots like Google and others how it wants to be indexed. You add robots.txt to the end of any website, and if they have it, yep, they have it right here. So this says, here's my sitemap, disallow / for user agents, Google and other, disallow this for all these other user agents, disallow this. These are the things you don't want indexed, for example. So you don't want your login page and error pages and stuff indexed. It's also a way of keeping secrets. You can say, don't, disallow my secrets directory or my database directory. That's not secure. It just keeps it out of the search engines. A lot of people started doing this now for AI, telling AI, do not index my stuff, do not consume my stuff. Of course, they ignore that because they want your stuff. But that's what robots files are good for. They're also commonly used in capture the flags for hiding stuff. So always look for robots file. Directory traversal attack, being able to take a website and say, I don't want to look at the base page. I want to look at .. // password, right? That would be the system's password. I do not expect to get anything here, but I got to try it. Okay. So an insecurely configured web server can spill its guts if it's misconfigured. Show all the system accounts. PHP and JavaScript vulnerabilities. So these are server side and client side based vulnerabilities in code. So code that's either built into the web page for PHP, for example, or built into the client side for rendering using JavaScript. We actually have a challenge that does some JavaScript vulnerabilities, has a JavaScript vulnerability today, and it's one of the challenges we're going to look at. As well as a lot of websites are, if they have a backend database like this one probably does, then behind the web server is a database server. And most databases are using SQL, some form of SQL, either MySQL or a SQL Server, and they can be vulnerable to SQL injection, which is a way of injecting commands directly to the database through the web front end to pop data and pop things that are not supposed to be accessible. Really dangerous stuff. Let's look at some web pages real quick. So HTML markup. If you haven't done HTML before, it's really simple. I used to, when the web first came out in the 90s, I taught this. I kind of learned by teaching. So in this case, this looks like the NPR website. Here's the head of the HTML file. Here's the body, and you see opening tags, closing tags, opening tag, closing tag, opening tag, closing tag, and then headers and link lists within it. So it's all very structured. It's not really fun to read, but you can search through it really pretty quickly by hitting Control U, like we said. These are normally stored as just regular flat HTML or HTML files on most web servers. Most modern pages are using JavaScript, which is client-side rendering. So it's code that's in the actual page to execute scripted code JavaScript on the client side. So in the old days, things only ran on the server side. Now they run mostly actually on the client side nowadays. So if you're going to learn, if you want to be a web developer and you want to learn one language, check out JavaScript or some other framework based on that. We talked about Control U, or we're going in developer mode, developer tools, very useful. So this is kind of what a client server session looks like. So above TCP/IP. So this is what's called layer 7. This is up at the application layer. The browser is talking to the server. So underneath this, you're going to see all the we're abstracting ourselves from TCP and the IP layers. But at the application layer on port 80 or 443, we're doing HTTP GET. The web server goes out, grabs the file from disk, and then sends it back to the client over that TCP session, TCP connection, and it was then rendered. That HTML is then rendered on in the web browser itself. So if you haven't played around with this much, it's very useful, because this knowing and understanding how this works is what enables you to use the curl command and modify these gets and puts, and so modify how you're talking to the server and what you can get back, modifying what you can see from the server when you get stuff back. So very, very powerful. Let's look at one of these challenges under design and development. Like this is the category that have things like architectural design, testing, integration, research, and development. So actual software, writing software. Let's look at the challenge that's so meta. So design and development. There it is. That's so meta for 10 points. For 10 points. This is just titled That's So Meta. What is Voodoo Goat hiding in his homepage? So basically, he's hiding something. What do we think he's hiding? What's an idea? What would you guys do first? He's hiding something. What should we look at?
Maybe view source first.
Definitely view source. Yeah, thank you, Michael. Definitely view source. So right off the bat, I see some things comment. Always look for comments. Web developers like to put their secrets in comments. I don't know why, but it's so insecure. But I'm not seeing a lot of stuff here. But meta tag under head. Look, under meta flag. There it is, right here. I think this is it. Anytime you see flag, sometimes I'll just pull it up and say search for flag. It's easy. Yeah, so this was much easier than I thought. I hadn't seen this one in years. So if I was going to try that for an answer, I'd go over here and plug it in. Yep, good to go. Get points for that. Does it make sense? Yeah, some of Dave's challenges are a little more esoteric sometimes. This one was easy. These, I think this Voodoo Goat, that's one of Dave's website. Dave has these weird little cartoon websites he runs for challenges. All right, let's look at Wireshark. So Wireshark's really useful. We talked about this earlier, to analyze packet captures to find a flag. So answers are typically related to network traffic, although I have seen Wireshark used on USB data. So actually sniffing USB sessions with a USB device. I've also seen it sniffing wireless protocols. So actually reverse engineering some of the wireless protocols and handshakes built into wireless communications. But it's really designed for just doing plain old TCP/IP is how it was designed to capture. Before Wireshark, we used what's called TCP dump. So if I was on a server with no screen, for example, I could do a TCP dump of, and I'm not doing this as root, so I could do a TCP dump of, do I have ETH0 on the system? I can't remember. Yeah. So if you're on the command line, you would use TCP dump to grab the raw data, and you can grab the same data that you'd get from Wireshark. In fact, it's using the same library using TCP dump. So it's really, really handy, especially if you run this on a firewall. You essentially have a man in the middle with TCP dump that you can record and transport off the system, for example. So really kind of cool stuff. You can kind of watch traffic real time. And you can even grep for things you want. Instead of using like, a big Wireshark install, you can just run this and pipe this through grep to look for specific patterns. You can also use ngrep, which is for actual watching network packets flow. So really, really cool other than Wireshark, but TCP dump kind of started it all, and then Wireshark kind of built on that. Does anyone know what Wireshark was called before it was Wireshark? Come on, some of you old timers.
Ethereal.
Ethereal. I like to see how people pronounce it. Some people say ethereal. It's like, yeah, it was when Ethereal first came out, everyone's like, whoa, look, it's like a GUI on top of TCP dump. So, but then it really started taking off and became super, super powerful. So let's look at some of these. Let's well, I'll just use Dave's examples here. So this is an example, and this breaks down the packets. Here's the packet number on the left, time sequence, the source IP, destination IP, protocol being used, the length of the packet, and its various info like what source and destination ports and things like that. So this is a port 80 to port 42994. So what is this right here? What is this one packet going from and to? Do you guys think? Since it's going from port 80 to port 42994, what does that tell you? What's responding to what? What runs on port 80, guys?
Like maybe a web server
A
responding
web
to
server.
a request.
Yeah, exactly. Someone put in a client request here, and if you look at I don't see the ports for this, but this is definitely HTTP, and at the TCP level, it's saying, hey, this is something on port 80 responding to something on a high port. Clients typically reach out to web servers or any server. Anytime you connect to a server on the internet, you connect over high ports, which are the ports between 32,000 and 65,000. So that means I reached out on a high port and I'm getting an answer back from port 80. So that's definitely a web server, or looks like anyway, a web server communicating back to the client that asked for something. So that's exactly what that is. So this information is very, very powerful over here. You can write these very powerful, and in fact, the way they got this greatly reduced information here is by writing a filter. So this is said, I'm going to look for IPs with the destination of this, and it's a double and is a logical and where TCP port equals 80. Equals means encoding language, and encoding that's a comparative analysis. Typically, if you have a single equals, that's setting something equal to. So anytime you see ampersand or equal, these are comparators and operators. So this is an operator, and this is a comparator. So it's basically if, where the IP equals this, and the port equals this. So very powerful kind of query syntax you can type in here to greatly reduce all the noise you're looking at in Wireshark by default. Here's some of the examples also. Should just show me packets from this. So IP source, packets to and from port 80. So this is not source or destination. This is just port 80. Anything going to or from port 80, show me that. From this to this, you just want to see one session between these two machines on the internet. That's really useful. Show me with the source of this and destination of that. I might double up on that and say just IP this and this, so I get both sides of the conversation, because this is only a one-way. This is a one-way direction here. This is only this source talking to this destination. Well, what about when it answers back? I want the opposite of that too. So I might remove the SRC and DST and just have IP equals. That way I get both sides of the conversation. You see that? And then to and from on port 443. So this is both sides of the conversation on port 443, wherever port 443 and that IP are mentioned. So really handy to be able to write those quickly. I mean, you can really, this will save you hours of scrolling through packets if you can just get a basic understanding of how these filters work. Excuse me. So common protocols you'll see in PCAP files and on capture and Wireshark and capture files. HTTP, of course, FTP, TFTP. Does anyone tell me what TFTP is? What it's used for? Anyone? What's FTP?
It's for uploading primarily Cisco firmware. Yeah, it's a
yeah.
UDP-based file transfer.
Cisco still uses that, huh? Oh my. Yeah, FTP is a terrible protocol. It's ancient. It's all clear text, unauthenticated. It requires multiple ports. So there's a port 20 and 21, I think, are used. So it used to be a nightmare to work with firewalls, but it's very insecure. If people are still using it, that's bad. TFTP is a trivial FTP, which is just for bootstrapping systems. So back before all systems had the ability to boot themselves off disk, they would boot off the network. And actually, it's still commonly used with everything from high performance clusters, where they don't want to have to put a hard drive in every single cluster node, to your home router, your home your home cable router will power up and make a TFTP call out to Comcast, for example, and say, "Hey, I'm checking in for any configuration updates. Like, are you making me faster? Are you making me slower?" And people will often attack that and hack and set up their own TFTP server because it's untrusted. It's not really trustworthy. There's no authentication or anything, and they can totally hack their own, cable modem to like go from 100 megabit to multi-gigabit speeds. You can rewrite the configuration if you're reverse engineering the configuration. So some pretty scary stuff. A lot of people use these technologies and don't really understand that they're not secure, and they're very, very vulnerable. Telnet, same kind of thing. This was back in the day before SSH. All we had was Telnet, which was clear text, totally clear text based chatting, basically, and I'm sorry, connecting to other systems. SMTP, traditionally unencrypted. Simple mail transfer protocol, port 25. If you don't know these ports, by the way, these are really good ports to memorize. SMTP 25, POP is 110, IMAP is 143, and then the SSL varieties of those, the POP S, IMAP S, and then they have the TLS versions of those that run on these same ports here. But for email communications, those are really, really important. If you ever see port 25 traffic on a packet capture, that's email, man. You can read email with that. Kind of scary. Protocols you want to typically ignore unless you have the key, unless you have kind of reverse engineered the key, or you got a hold of the key somehow, the session key, or you did a man-in-the-middle attack. You typically can ignore the HTTPS, SSH, SFTP, and SMTP S, which is port 465, port 993, 995. Those are the kind of SSL based. Newer ones use TLS back on these ports here. So if you open up port 25 and you see gobbledygook, it looks like it's encrypted. They're probably running TLS, which is kind of you start the session and then you immediately switch to an open SSL encryption within the port 25. But these you can typically ignore because unless you have the keys, you can't crack them. It'll save you time. So you can filter them out. Let's look at an implementation and orientation challenge. So implementation and orientation, again, is the kind of where your I don't know if I mentioned this, but sysadmins and DBAs, network administrators, system security folks, tech support, help desk are typically where these people would. This is the category that their jobs would reside in. We're going to look at this Ethernet to IP challenge. So let's look at Ethernet to IP. Implementation operation. What am I looking for? Ethernet. Yeah, Ethernet to IP. So this kind of gives me a hint right away. Ethernet to IP. Yep. What is the internet protocol address? IP address. What's the IP address of the host at blah in the attached packet capture file? Free hints. The IP address is a sequence of 4 numbers. Okay, I'm not an idiot. I know what an IP address is. And Wireshark, use Wireshark for this. It's available, blah, blah, blah. You can download it. Okay, let's download a PCAP file. So you've never done this before. This is a good one to start on because this is pretty simple. And it's kind of your training wheels to get started. There we go. I just like pulling it directly up. Like I'm a command line guy. Put it in the background. Well, that's a pretty simple PCAP. There's 2 packets. All right, so what are we looking for? It kind of caught me off guard how small it was.
That's the name.
What's the IP of the host at? What is this? Does anyone know what this is?
VMware.
What's under What's good answer? What's
So,
what's under an IP address?
MAC address, yes.
MAC address, right? If you remember your OSI layers, or do you guys teach OSI? Or do you guys teach the Microsoft 4 level
OSI.
OSI? Okay, so if you know the OSI, then under IP is MAC, Medium Access Control Address. And so, and someone said VMware. Is this VMware here?
Yes.
Yeah. So the first 2 bytes of your MAC address tell you who the vendor is. So someone could say, hey, what type of laptop was that attack launched from? Check it out. You can look this up. And it may give you, it may say Lenovo, but chances are it'll say something like Intel or VMware or something. But at least you know kind of it didn't come from a Mac or a PC at this point. We know this came from a VMware MAC address. And the rest of these are what gives each machine its unique identifier. So let's go ahead and look at the ending in C2E2. I just look at the last four digits on the last 2 bytes. C2E2. What happened? Did I lose it? Oh, here we go. So C2E2. What's the MAC address? Well, the IP address that goes with that. What was the name of this challenge? Ethernet to IP. I clicked on the wrong thing. There we go. All right. So C2E2. So here there's only 2 packets here. So C2E2. That's the destination, and so it's that, right? And it says it down here too, destination. So destination is a VMware. Oh, so it came from VMware too. That's interesting. OOC is also VMware. Huh. Okay, so I guess my answer is this. 192.168.28.2. I mean, really, there's only 2 options, right? There's only 2 IP addresses in this challenge. Oh no, I got it wrong. Destination. If someone sees me doing something wrong, call me out here. Destination 192.168.28.2. Oh, .28. Typo. Tweaks fat finger. I'm the king of fat fingers. Maureen can tell you. Yeah, there we go. All right, so that one's solved. That was pretty easy. Some of these are really good intros to getting around Wireshark. These PCAP challenges. We got tons of them. Okay, we're good there. Any questions before we keep going on Wireshark?
Yeah. So in the academic world and in this Virginia cyber range world, I used to be a pen tester for DHS. We have a lot of spoofing of MAC addresses to hide who we are, or we would use proxies to hide who we are. So to use this in the reality or real world, you have to be aware of that. Just a FYI for people.
Yeah, MAC address is not hardwired. In fact, most phones now have the anti-tracking capability of randomizing. It's called randomizing your MAC address or randomizing your address. And that's just so that, when you show up to school every day and the Wi-Fi system sees you, it doesn't see you as a person. It sees your phone's MAC address. And if you track MAC addresses, you can track human behaviors and human movements and not even know who the person is. But then that turns into what's called metadata. So you connect that with the phone number and suddenly you can tie it to a person. Now you can track the person. So if you can glom on to any static non-changing variable, you can use that to accumulate metadata and build a database of behaviors and then tie them back to people. So that's why people mask their
eyes. The new trend is medical devices. Medical devices report to the cloud, and you can associate MAC addresses with people and call your nuclear strike in.
Yep. I don't know about nuclear. I think a little more targeted than nuclear, but yeah, in fact, I think in the Obama healthcare legislation, one of the things was the creation and registration of those medical IDs for devices. And so the medical system now has a database that tracks your insulin pump and your diabetes monitoring patch, and those all have MAC addresses, and they not all MAC addresses, but different types of addresses. Your CPAP machine that calls in every night. So all that stuff is essentially tracked. It's required by law to be essentially tracked by databases. So it's kind of scary stuff.
Yep.
So yeah, being able to know what a MAC address is and how to get around it is a good thing. But also learning how, like we just talked about, the first 2 bytes of the MAC address will tell you what the vendor is. So really useful stuff. Where are we time wise? Got about 20 minutes,
Yes.
I think. Okay.
Mhm.
All right, let's skip ahead real quick. Investigation, binwalk this way. So we're going to go to the investigation category. And investigation category is where your kind of cybercrime and digital evidence people kind of live and breathe. So this is more the more kind of CSI style cybercrime and investigations. So if you're interested in like the data side of the FBI, for example, this got to be you can imagine those kind of jobs being more common there. We are looking at binwalk this way. Look at this. Oh, steganography. So steganography is the practice of hiding things in plain sight. So typically files within files in this case. More steganography, you might need some more advanced tools for this one. So when I see steganography, it's typically some kind of document or image file with other stuff inside of it. So I'm going to download this. Looks like we can buy a hint if we want to. I'm just going to go and show you guys the hint. Hint, one way to solve this challenge is using command line tools called binwalk. It's easily installed on both Linux and Windows, Mac operating systems. Okay, thank you very much. Now, I would have had to pay for that hint. Normally pay 8 points, it looks like. So if you don't want to pay, and by the way, the way our challenges work are, if you buy the hint, you pay for it, whether you solve the challenge or not. A lot of people get upset with like, well, I didn't solve it. Why are you charging me? It's like, well, if you buy a Snickers and take a bite out of it, then it's yours. You bought it, sorry. So just to be aware, when you buy a hint, you or your team pays for it, regardless of whether you solve it or not. Just so no one gets upset. Let's see. So top 10. What is this? It looks like a JPEG file. So I'm gonna.
Hey, Tom, I got a question for you.
Yeah.
So we're working on some of the old CTFs under Virginia Cyber Range, and they have test, and then they have submit. If we test, do we get penalized on points?
If you're both an administrator and a player, I think you can be administrator, but if you're seeing the test button, test you do not get charged for.
Okay.
I don't know why you'd see both test and submit. Normally only players see submit and CTF admins see test. So I'm not a player right now, so all I can do is test.
Yeah, and where I'm logged into from Germana, I see both buttons.
Really? Well, test will not charge you. Typically, that's only teachers or CTF admins will see test.
Okay, thank you.
Is the short answer.
Yeah, I would say that the submit button probably shows up when the CTF is live, since this is not live yet and for another 45 minutes or so.
Well, I know for me it never shows up if I'm logged in as maybe because I'm a super admin. I don't know.
Oh, maybe.
But yeah, you're correct in that test doesn't charge you and submit does charge you. So just FYI. Thanks for that. So I'm going to point Firefox at this file. Okay, it looks like it is a legitimate JPEG. There's just top 10 security jobs. Okay, so sometimes I'd point steg hide at this. Steg hide, and then point it to the file. But they already told me my hint said use binwalk, so I'm gonna do a binwalk top 10. Okay, it looks like there's stuff there. At this memory address, it found a JPEG. At this memory offset, it found this message. I don't know why it told me about that. And then at this memory offset, this memory address, it found gzip file. Hey, there we go. Let's see. Now, I'm not too. I haven't done binwalk in a while. Let me see if it actually did anything, or if I got to tell it to do something. I think I need to tell it to do something. Yeah, I need to tell it to do something. So, again, if I'm not familiar with it, which in this case I haven't had my second cup of coffee, so I'm not familiar with it, I'm going to look at the man page. So, man page, tool for searching binary images for embedded files and executable code. Okay, yeah, I know what I want in here is very concise. There it is, extract. That's what I want. So I'll do same command, -E for extract, and boom. Should have done something useful for me. Ah, there we go. It's created a directory. Ah, that's a good sign. Go in there, look around. There we go. Made a GZ file, and it looks like it un-GZ'd it. GZ is GNU zip. So I think this is the file. I'm going to run a file on this just to see what it is. Oh, it's a tar archive. Okay, so tar xvf file name. Tar is a tape archive. It's like a zip before zip existed. I'm going to untar it. Oh, look. No flag here and flag is in here. Well, that's weird. Well, I want to look at the one that's flags in here. So my other text viewer or my other graphic viewer sucks. So I'm using Firefox to look at images. Oh, was that it? Oh no, this is an image. I gotta type it. Ugh. Why is it? They have another file called no flag in here. This is that I'm giving you my thought process because this is how I always look through everything first. Okay, I think I remember how this originally worked, which was this PNG was embedded within this bigger PNG. See how this one's smaller? That's the answer. That's the flag. It was. I think it's actually embedded in this file here. In fact, if I bring it up just to prove that, I think. Oops. Hex edit no flag here. It's a PNG. What's the other file? It's also PNG. Watch this. If I go over here and search for PNG, okay, there's that, and then, oops, oh no, I don't want to modify it. Hold on. PNG. I've only got like 15 minutes left, so. Okay, never mind. I'm on a rabbit trail. So time management and identifying rabbit trails is important because you can go down a rabbit hole and never come out and then realize the game's over and you've lost. So being able to do this stuff quickly is important. So I would bring this up in your preferred graphic viewer and type this in or pump it through some kind of what do you call that? Decoding images to text. You could do it that way, but most people are just going to go ahead and type it in. So if I had more time and energy, I'd try typing that in to the challenge, and I can say test, and it'll show me the answer. And there it is. So I have two regexes here. I have a regex and a string. This regex will capture upper, lowercase, and global match. And this string was the original answer from when this challenge was written. So cool. Let's move right along. All right, so different high school level competitions. Is the majority of this group high school or university or community college? Someone who knows our attendance today? Anyone? Most of our attendees today are what? From where? Can you guys hear me?
Yeah, thanks. Looks like folks are replying in the chat.
Oh, what are they saying?
Variety, high school, I'm in grad school.
Oh, wow. Yeah,
New grad, university.
Cool. Yeah. Okay, good. I'm glad to hear that. That's awesome. So high school competitions are really starting to grow now. Before it was more of a university type thing, but they've really taken off at the high school level. So Pico CTF is an annual one run by Carnegie Mellon's Scilab. HSCTF is the first CTF by high schoolers for high schoolers. So that's really cool. Radford University here in town runs their own CTF every year. They have a CTF here at Virginia Tech, but they also have a hackathon. They run hackathons are also popular. Sometimes you'll see CTFs at hackathons. Hackathons are typically more developer code writing type stuff, but you'll also see CTFs. And then Cyber Patriot is of course the big blue teaming annual kind of CTF challenge that they have nationwide. The collegiate level, Seesaw CTF is an annual one at New York Poly. DEF CON, of course. DEF CON's the big civilian one that the hackers out in Vegas run every year as part of DEF CON. Collegiate Cyber Defense, lots more. Check out ctftime.org. That's where a lot of these CTFs are tracked, where people can register answers and solutions for the challenges. And if you want to be on, you want to be on like an elite CTF team, track how much stuff you've contributed to CTF Time, how many solutions you have and where they are, where they're documented, if they're on your GitHub or on CTF Time or wherever. Put that in your resume. It's good stuff. And speaking of CTF Time, so this is kind of what it looks like. So it's basically your central repository of all CTFs going on at a given point in time. Worldwide leaderboard. I didn't know about that. That's cool. Calendar of upcoming CTFs. So you can go out there and say, hey, what's coming up? I want to keep sharp over the summer. Really good place to also find solutions and write-ups.
Rochester has a great one too, or IT in New York.
Yeah, they're popping up everywhere. It's really shocking. It's really cool though, because it's a really fun way of learning. You can come in literally any level and always have fun. And even I write a lot of these challenges, and what I love is learning something new. So I learned something new in writing these challenges, and our players on the range learn something new. And most of you teachers, right? You guys are going to learn something new every time you get some of these new challenges. And we're about to publish a whole bunch of new content that we've been building up since 2021. So get ready. We're going to open the floodgates. Facebook even has its own CTF. I didn't know about that. Wow. Trivia questions. King of the Hill. All right, cool. Also, you can also host your own. You can download CTFD and run it on your own Raspberry Pi or your own server and run it yourself, or pay them $50 a month and they'll do it for you. MetaCTF is a friend. It's a friend of ours. Started his own CTF, Roman, and really awesome system. He and I have talked to several of our events, and I love it when he comes and plays and he like totally sweeps the floor with everyone. And we actually have to ask for him, Roman, can you please like kind of play in the background, because you win every single competition you play. So he loves it though. He's still got his mind in the game. And of course the US Cyber Range, if you want to host just a CTF and not buy all the stuff that normally comes with the Cyber Range, just run a CTF. We can do just CTF. I think it's like $60 a month for up to 100 users. So it's really cheap. Okay, so go ahead and play the CTF. Looks like I'm almost on time. Go out to that URL, click start, and sign up.